Homework 14, Logarithmic Functions, Video 5, Domain of a Logarithmic Function, as was not so subtly foreshadowed at the end of the previous video. Let's get right into it. Find the domain of f of x equals log base 2 of x minus 5. Now, in order to justify what's about to happen, let's pretend that we already have something to represent the answer to this logarithm. I don't know what this answer is, but I know what the answer does. The answer to a logarithm is a power that turns the base into the argument. So whatever the answer to this logarithm would be, it would be the power that turns the base into the argument. Now, why do I want to bring that up? Because in the previous video, we talked about things that look like this. Well, I'm going to use a new function, but I'm going to use that. I know normally it would say g of x, but I'm saying g of square. Why? Because I don't want to use an x again. I've already got it in use. But when we graphed a function of that form, when we did it last time, it was f of x equals 2 to the x. So please forgive my duplicitous use of the variable x here and the variable x here. But I know what that graph looked like. It looked like that. And what that means is whatever comes out of this function, whatever this is equal to, has to be greater than 0. Well, this is equal to that, which means that this must also be greater than 0. It may be a little bit highfalutin, me waving my hands and saying, well, this has to be greater than 0, so this has to be greater than 0. But the main reason for what I'm about to say is based on the fact that the range of an exponential function is 0 to infinity, an exponential function that hasn't moved up or down. So what does that mean in the terms of finding the domain? Well, to find the domain, all you have to do, let me get a new black marker. These black markers don't last me very long. Got a whole stash of them over here that start skimping out on me. All you have to do to find the domain of a logarithmic function is solve argument greater than 0. Well, here's another way to think about it. Whatever the answer to this is, the power that you put on the 2. If you put a positive power on the 2, you get a positive number. If you put a 0 power on a 2, you get 1. And if you put a negative power on a 2, you get a reciprocal of a positive number that can get really small but never hit 0. So in other words, 2 to any power will always be greater than 0. So this argument must be greater than 0. So all you have to do is solve x minus 5 is greater than 0. You get x is greater than 5. On a number line, that's everything to the right of 5 but not including 5. And as an interval, parentheses 5 comma infinity. So there's really not a lot to say about finding the domain of a logarithmic function besides this is your setup. You solve the argument greater than 0. Now this setup can invoke other issues like, oh no, do I have to flip the sign? Or even worse, oh no, do I have to partition the number line, pick test values, see if they make the inequality true or false, and then keep only the intervals that make it true. So you're going to see some residual content from days gone by in terms of solving inequalities. But I don't want to dwell too much on how to solve the domain of a logarithmic function because in a sentence, you solve the argument greater than 0.